Okay, today we're going to talk about simplifying radical expressions. And so we talked about yesterday how to simplify a perfect square. So we're going to use that knowledge plus some new information to simplify radical expressions involving variables and cube roots. Okay, so simplifying a cube root is a lot like simplifying a perfect square or square root because it's the same process. It's just a cube instead of a square. So let's look at our notes. So a radical is written as follows: n square root or nth root of a. We read it as the nth root of a. Okay, so you're used to seeing it as a square root because normally that's a 2, and like exponents, when it's a 2, we just assume that that's what it is because we're so used to saying square root. So the new thing is that it could be any number. It could be a cube root, it could be a 4th root, it could be a 5th root, and so on and so forth. So this number here, the index, tells you which root you're looking for, meaning how many times did the number get multiplied itself. So if I'm going to have a number under here like 64, I'm looking for which number multiplied 4 times by itself to get 64. I'm going to get 2. Okay, so to simplify a radical expression, you determine the index, meaning you identify what it is. Based on that index, you simplify the number. So if it's a perfect or if it's a square root, you're looking for a perfect square. If it's a cube root, you're looking for a perfect cube. And then using the index, you simplify the exponent on the variable. Alright, so these notes, write this down so you know the vocabulary. Indexes the vocabulary, simplifies vocabulary. But really, to understand this, you just kind of have to look at examples. So let's do an example. So example 1 says simplify the radical. We want the cube root, so it's a cube, of 24x to the 5th y. So, first I need to deal with my 24. In this case, I'm not looking for what perfect square went into 24. I'm looking for what perfect cube went into 24. Alright, so my perfect cubes go 8, 27, 64, 125. So that's 2, 3, 4, and 5 cubed. 2 cubed, 3 cubed, 4 cubed, 5 cubed. For cubes, that's really all as far as you need to go. For perfect squares, you need to go a little bit further. Okay, so looking at these numbers, the only number that will divide evenly into 24 is 8. So I'm going to do the cube root of 8 times the cube root of 3, because 8 times 3 is 24. So now the cube root of 8 is 2, because that's what we multiply by itself. And underneath the radical, I'm going to leave some space, we still have a 3. Okay? But now we have letters as well. So when you're dealing with the variables, you're looking at the exponent, and this is what I do. I divide 5 by 3. Well, 3 goes into 5 evenly once, so that means 1x is going to come out. Then 3 into 5, it goes in once with 2 left over, so I'm going to have x squared still underneath. Okay, so 5 is divisible by 3 once, so 1 comes out. 5 minus 3 is 2, so 2 stays in. Does that make sense? Then the cube root of y, well, 3 doesn't go into 1, so it would just stay underneath. Okay, so when you're dealing with the variables, you divide the number by the index. However many goes into it evenly comes out. However many are left stays in. Alright, so like if I did the square root of x to the 4th, well, this is a 2. 2 goes into 4 twice, so x squared would come out, and it would just go away the radical sign. Okay? Let's do another example. So now we have the 4th root of 64x to the 8th y to the 7th. Well, the 4th root of 64 is equal to 2. And I know that just because I know it. But if you didn't know it, you could like start dividing numbers to see which one would go into it. Okay, so the square root, or the 4th root of 64 is 2, so that comes on the outside of the radical. I'm going to leave some space because most likely some number is going to come out. 4 goes into 8 twice, so an x squared is going to come out, and nothing's going to be staying underneath. 4 goes into 7 once, so a y comes out. Then 4 into 7, that would be leave us with 3, so we would have y to the 3rd left. Okay, so it's division, but then thinking about what your remainder would be, and your remainder becomes the exponent on the variable. Okay, so this would be your final answer. And these are simplified answers. You're not solving anything, you're just simplifying. So let's do one more example. Say we have the square root of 27, x to the 5th, y to the 4th. So now I know that this is an imaginary 2. So I'm looking for a perfect square that goes into 27. I know it's going to be the square root of 9 times the square root of 3. So that would be a 3. Leave some space. Under the square root stays a 3. Then 2 goes into 5 twice evenly. And we have, that would be 3 left. Then 2 goes into 4 evenly, so 2 goes into 4 twice, so it would be y squared. Okay, so my final answer, to see it written out better, be 3x squared, y squared, square root 3x cubed. So to double check, you need to multiply back. So 2 times 2, oh, this should just be an x, sorry. Erase that. Erase that. 2 goes into 5 once, so a 1 comes out. So 1 times 2 is 2, plus 3 should be 5. That's a good way to check it. See, I didn't check my work, and so that's why I wrote it down. And then 2 times 2 is 4. Well, we got a 4 there, so that was right. Okay, so to double check, you go backwards, you multiply. That should be nothing. Let's use our eraser. Okay, so that's how you simplify square roots with with variables. You just look for the perfect square in the number, and then you think about, well, how many? Because what I'm doing really is, so say I have x to the 4th, I'm doing the square root of x times x times x times x. Well, you're looking for pairs because it's a 2. So there's 1 pair, there's 2 pairs. So that would be x squared comes out. Okay? We'll work on this in class tomorrow. If you're a little confused, that's okay, but make sure you took good notes, and we'll talk about it in class tomorrow. I hope that you watched your video and took good notes. I hope you didn't just copy your friend, because that's not very good, and it's going to make you fail a test again. Some of you. Alright, have a good night.